Hello Year 7s, it is lovely to see you back here in Physics Corner so soon. Following on from yesterday's video about the wheel and axle, today we're going to be learning about a very specialized type of wheel and axle, gears. Gears are different to a regular wheel because they have little teeth all around them called cogs. These cogs are so amazing because it means that multiple gears can connect up together and make a gear train so that when one gear moves, the other gear moves as well. Now there's a few important things to know about when two gears move together. Number one, there is a driver gear and a follower gear. The driver gear starts off the movement and the follower gear follows. Number two, they move in opposite directions. So when the driver gear moves clockwise, the follower gear moves anti-clockwise, and vice versa. Number three, and this is an important one, when the driver gear is bigger than the follower gear, this is great for generating speed. When the driver gear is smaller than the follower gear, this is good for generating force. Don't worry, we're going to look at how this works now using this gear simulation. So let's start off with our driver gear and our follower gear being the same size with the same amount of teeth. The driver gear is on the left and moving clockwise, and the follower gear is on the right and moving anti-clockwise. When both gears are the same size and have the same number of teeth, this means that they're going to move at the same speed, which for us right now is 10 rotations per minute or 10 RPM. Now let's see what happens when we make the driver gear twice as big with twice as many teeth as the follower gear. But we're going to keep the driver gear at the same speed, 10 RPM. As you can see, now that the driver gear has twice as many teeth, the follower gear is going twice as fast at 20 RPM. It's worth noting though that now that the driver gear has twice as many teeth, so 20 teeth, it's going to take twice the amount of force to keep it moving at the same speed of 10 RPM. So even though we have the follower gear moving really fast now, it's going to take twice the amount of force to do that. And finally, we're going to see what happens when the driver gear has half the amount of teeth and so is half as big as the follower gear. And of course, we're going to keep the speed the same at 10 RPM. So now because the driver gear has half the amount of teeth as the follower gear is going to go half as fast as the driver gear at 5 RPM. And this time, since the driver gear has half as many teeth, it's only going to take half the amount of force to keep it going at 10 rotations per minute. Now another way to understand this is by looking at bike gears. But bike gears actually move in the same direction because they're connected by a chain. When we're looking at bikes, the driver gear is the one that the pedals are attached to, and the follower gear is attached to the back wheel. Being on a high gear in your bike means that your gear is bigger and has more teeth. And just like we saw before, when the driver gear is bigger than the follower gear, it means that the follower gear, so the wheel in this instance, goes faster. And we can see this happening right here in this simulation. So when your bike is on a higher gear, you can go faster, but it does take more force or pedaling harder to get there. We can see in this simulation that each time the driver gear or the pedal gear moves around one rotation, the follower gear or the wheel gear moves around about 1.5 rotations. Now let's have a look at the lower gear. When your driver gear has less teeth, then your follower gear doesn't go as fast, but it's much easier to pedal because you don't need as much force. So that's why it's best to switch to a low gear when you're going up a hill, for example. Here you would have to pedal 2.5 times just for the wheels to move around one time. Now let's have a look at me demonstrating this on my bike. First, let's have a look at me using a higher gear with more teeth. Now, let's have a look at me using a lower gear with less teeth. As you can see, I'm pedaling much slower on the higher gear and much faster on the lower gear. This is because it takes me more force or harder pedaling to pedal once on the higher gear with more teeth than on the lower gear with less teeth. Now let's count how many pedals it takes for me to make it all the way across in the higher gear compared to the lower gear. Let's start with the higher gear. Looks like it's 1.5. And now let's look at the lower gear. 1, 2, 3. So as you can see, to get across in the higher gear, it takes less pedals, but harder pedals to get there. And on the lower gear, it takes more pedals, but they're very easy to do. So there you have it, that's gears. When the driver gear is bigger than the follower gear, you can go much faster. When the driver gear is smaller than the follower gear, you can generate more force more easily. Thank you so much, Year 7s. Happy Tuesday, and I'll see you next time. Bye! When two at the same speed of 10 RPM.